Assalamualaikum and a very good morning to Sir Muhammad Nizam bin Yusuf as my final year project supervisor, my beloved second examiner Dr. Faiza Buyong and Dr. Amira Amalina Ahmad Tramizi as a panelist. Let me introduce myself first. I am Noor Alia Erina BINTI MUSTAFFA from AS 2296A. Today I will present my final year project part 2, which titled Preparation of Activated Carbon from the rice husk for the treatment of the laundry wastewater. So for the intro, according to Ulismia in 2017, activated carbon is defined as a bioabsorbent with high absorption rate. This is due to the large surface area, microporosity, chemical reactivity, and the hydrophobic nature. Activated carbon can also produce through the carbonization and either chemical, physical, or chemical physical activation. One of the functions of activated carbon is to remove wide range of the contaminant, such as trihalomatic. Activated carbon can also reduce the amount of CO2, which can contribute to improve the environment and the health outcome. Now let's move to the production of activated carbon. Global rice production increased from 2016 to 2017 by 2.9 million tonnes. Meanwhile, according to the Jani in 2017, Malaysians have produced more than 3 million tonnes of the rice husk in the 2017. The production of the rice can result in the significant amount of the rice husk waste. So the excessive production of the rice can lead to the significant accumulation of the rice husk waste, which result to the environment pollution, waste management challenges, economic loss, and potential greenhouse gas emission. However, the rice husk waste can also have potential for various applications which can benefit to the company or to the environment. For example, using the rice husk in the production of the activated carbon can result in more affordable and sustainable and environmental friendly resource. Next, the problem statement is stated in this slide. Firstly, the wastewater treatment for both residential and the industry can be expensive due to the advanced technology. As we can see in this slide, wastewater treatment plant Kuala Lumpur use the most up-to-date equipment and is costly. Next, the agricultural waste can be the breeding ground for the rodents and other pests. So the mismanagement disposal of the rice husk can cause inhabited of the rodent. Lastly, the laundry wastewater can cause unpleasant view and polluted the water source. The first objective of this study to prepare activated carbon from the rice husk using the chemical and thermal activation processes. Next, to determine the characteristic of the activated carbon prepared from the rice husk. And lastly, to determine the performance of the activated carbon from the rice husk in the reduction of the pH, turbidity, COD, and the phosphate from the laundry wastewater. So for the significance of study, the first one is to help to find the cheap and practical solution to treat the wastewater from the laundry premise. And second, cost effective and employing in the reduction of components that result in the undesirable taste and odor. And lastly, to give value to the rice husk, which can help to give extra income to the farmers. Okay, next is the literature review part. So you can see there are a few of the previous study or the study case that have become the use for this section. So let me explain about it briefly. For the first one is the Hanun in 2017. It's explain about what is the activated carbon and the type of the structure activated carbon and the use of the activated carbon. And second one is the Jia in 2019. It's explain about the how well activated carbon become the absorbent. And the third one is ASTT. Which explain the preparation of the activated carbon and application for the laundry and the wastewater treatment. And the fourth one is the APCON, which demonstrate the reduction of solution particle, color, POD and COD from the wastewater obtained from the hair salon. And the five is the Watinisha, with impact the laundry wastewater can be minimized by controlling the water polluting or the increasing the quality of the waste through the wastewater treatment. So for the methodology, the rice husk can be collected and cut into smaller size and placed using the distilled water. The rice husk must be weighed for 100 gram and stored in the 0.5 mol of the KOH on the shaker overnight. The rice husk must be heated in the furnace at the 8 degrees Celsius for 2 hours. When the rice husk is soaked in the KOH solution, rice husk has been impregnated by using the KOH for the activation process. The physical activation happened when the rice husk was heated in the furnace for 2 hours at the 8 degrees Celsius. This process is the first objective, which is to prepare the activated carbon from the rice husk using the chemical and thermal activation processes. Next, rice husk activated carbon have been characterized using the scanning electron microscopy and the FTIR machine. This step achieves the second objective, which to determine the characteristic of the activated carbon prepared from the rice husk. This will be discussed in the result. The parameter of the pH, COD, phosphate and turbidity is being measured by using the laundry wastewater to find the initial result of the parameter. So, after the exhaustion process, the wastewater have been tested using different amount of the rice husk activated carbon, which is the 1 gram and 3 gram of the activated carbon. This to determine which are the most effective amount of the adsorbent to be used, which can lead to the evacuation, exhaustion and the higher capacity to remove the contaminant. Then, the experiment continued by using the different contact time, which are 3, 30 minutes and 60 minutes. After the exhaustion process, the final measurement of the parameter are taken. The reason why we use the scanner electron microscopy to determine the characteristic of the activated carbon due to its ability of the high resolution imaging, which can allow for the visualization of the structure, morphology, pure structure and the particle size of the activated carbon. On the left side are the result of the SEM photograph at the 500 time magnification with the 200 nanometer pore size. In this photograph, we can see the microspore, which are size larger than 50 microspore, have the largest pore size. Meanwhile, at the left photograph show that the SEM photograph of the 3000 time magnification and 13 nanometer pore size. This photograph show the smaller diameter of the 13 nanometer. The characteristic of the rice husk activated carbon in the SEM is the mesopore structure with the pore with the diameter around 2 until 50 nanometer. The mesopore structure is the intermediate size between the smaller microspore and the largest microspore. The second method to determine the characteristic of the activated carbon is using the Fourier transform infrared spectroscopy analysis. The FTIR transmission is the method to identify the surface chemistry of the material and the functional group present in the sample. FTIR was performed to evaluate the surface functional group on the rice husk activated carbon. So, the highest peak which can be found in the result are 3564.2 cm -1, which was attributed to the OH vibration in the hydroxyl group. Hydroxyl group contribute to the adsorption capacity of the activated carbon by facilitating the hydrogen bonding and interaction with the polar compound. This can optimize the performance of the activated carbon in application such as the water treatment and filtration. So this result of the FTIR show that rice husk activated carbon have the FTIR spectra content of the OH functional group, which is 2563.3 cm -1, and the skeletal C stretching, which is 1014.7. From the result, the structure of rice husk activated carbon contain many carbon bonds which are from the functional group OH, CH and CC. The raw material that we used in this experiment were rice husk, which is the waste from the agriculture and the organic component, including the hydrocarbon, polymer, carbohydroxide, lipid and protein. Since the FTIR spectroscopy is commonly used for the analysis of the organic material, the presence of the carbon-based compound is prevalent. This slide shows the result of the adsorption dosage. Adsorption dosage is referred to the amount or the quantity of the activated carbon used in the specific adsorption process. The absorption dosage is important parameter in determining the effectiveness of the absorption process. For this experiment, I use 1 gram of the rice husk activated carbon and the 3 gram of the rice husk activated carbon for the absorption. So, for the result, the graph of the COD version contact time show that 3 gram of the rice husk activated carbon with 3115 mg over L have the higher reduction than 1 gram of the rice husk activated carbon with 4560 mg over L. The percentage reduction for the 3 gram is higher than 1 gram with 38.39 over 10%. For the result, the graph of the pH version contact time show that 3 gram of the rice husk activated carbon with 9.54 pH has the higher reduction than 1 gram of the activated carbon with 9.81 pH. The percentage removal or the percentage reduction of the 3 gram is higher than 1 gram with 5.1% over 2%. Okay, next for the previous case study by the Agrawal in 2017 showed that the higher percentage of the AH or AC used in the absorption have the most reduction of the COD. You can see in the table below show that the higher percentage of activated carbon use lose the highest COD both after 7 and 14 days. The graph of the phosphate version, the contact time show that 3 gram of the rice husk activated carbon with the 3.85 mg over L have the higher reduction than 1 gram of the activated carbon with the 4.7 mg over L. The percent reduction for the 3 gram is the higher than 1 gram with the 30.28% over 24.5%. For the result of the graph of the turbidity version contact time show that 3 gram of the rice husk activated carbon with 65.2 NTU have the higher reduction than 1 gram with the 96.6 NTU. The percentage reduction for the 3 gram is higher than 1 gram with 15.14% over 35.02%. This can be concluded that the higher absorbent use the more effective and efficient the absorption process. By increasing the absorption dosage, generally increase the availability of the surface area and the number of the active site for the absorption, which can leading to the higher absorption capacity. This slide shows the result of the contact time. Contact time refers to the duration of the contact or explosion between the adsorbent and the activated carbon material. The contact time is important in absorption process as it influences the efficiency and the extent of the absorption. For the result, the graph of COD version contact time show that 60 minutes have higher reduction with 2050 mg over L. Then 30 minutes with the 3183.33 mg over L. The percentage reduction for the 60 minutes is higher than 30 minutes with the 60.32% over the 38.39%. Okay, next for the next graph show that the pH over contact time of the 60 minutes have the higher reduction than with the 9.71 pH than 30 minutes with the 9.51 pH. The percentage reduction for the 60 minutes is higher than 30 minutes with the 9.39% over the 5%. Next for the result, the graph of the phosphate version contact time show that 60 minutes have the higher reduction with the 3.5 mg over L than 30 minutes with the 3.79 mg over L. The percentage reduction for the 60 minutes is higher than 30 minutes with the 30.28% over 24.5%. For the result, the graph of the turbidity version contact time show that 60 minutes have the higher reduction with the 65.2 NTU than 30 minutes with the 96.6 NTU. The percentage reduction for the 60 minutes is higher than 30 minutes with the 55.14% over 35.02%. Okay, next I'm going to talk about the percentage removal. Okay, here you can see there are two tables of the absorption doses and also the table of the contact time. So you can see at the table, the most higher reduction is happen at the 3 gram of the absorption doses, which is the higher activate carbon volume. And at the contact time, the most absorbent or the most reduction happen at the 60 minutes. So it can be assumption that the absorption is most effective happen at the most activated carbon amount and also the most of the time taken. So in the conclusion, the rice husk can be prepared by using the chemical activation and also the physical activation process. So for the chemical activation, the rice husk have been implemented by using KOH solution, and the physical activation show that the rice husk can be burned in the furnace for 2 hours at the 8 degrees Celsius. And for the second objective, the characteristic of the activated carbon prepared from the rice husk can be determined by using the FTIR, which we can see the functional group of OH, CH and also CC have been determined, and the CEM have found that the mesopore structure as the characteristic of the activated carbon for the rice husk. Okay, and lastly, the performance of the activated carbon from the rice husk can be reducing the turbidity, pH, COD and phosphate from the laundry wastewater was determined. So the most effective result are absorption for 3 gram of the rice husk and in the 60 minutes. So we can see that in the pH there are reduction of 8.39% and in the COD there are reduction in 60.32% and the turbidity show that there are reduction in the 46.14%, and lastly for the phosphate there are reduction in 30.28%. Okay, here are some of the recommendation from this study. So for the first one is to choose the appropriate activated carbon type based on the specific absorption requirement, taking into account factors such as pouring size, its distribution, the surface area and the surface chemistry. And the second one is to determine the optimum doses or the amount of the activated carbon required for the effective absorption. The second one is to conduct experiment to determine the optimal contact number between the absorbent and also the activated carbon. The longer contact time generally result in the higher absorption.